Hello students, welcome you all to the video lecture on signals and system. Today we are going to discuss about Z transform of unit step function. So first we need to know the definition of U of n. Okay. So what is U of n? U of n is a discrete unit step signal which is given by U of n is equal to 1. It exists for n greater than or equal to 0 and it is 0 for n less than 0. So how we will plot the U of n? U of n is 1. Since it is discrete time signal, it exists at discrete instants 0, 1, 2, 3, 4 and so on. The amplitude is 1. So usually if it is continuous time signal, we will denote it by U of t. Since it is discrete, we denote it as U of n. And they have given it as Z transform. Okay, so Z transform we can apply only for discrete time signal. Okay, so Z transform and discrete time Fourier transform we can apply for discrete time signal. Laplace transform and your Fourier transform, Fourier series we can apply for your continuous time signal. Okay, so here in the question they have given just find Z transform of unit step function, right? So you have to take your unit step as U of n. Since Z transform we are going to apply for discrete time signal, so that you have to know first. And what is the Z transform formula? Z transform formula is x of z is equal to summation n is equal to minus infinity to infinity x of n z power minus n. Okay, so particularly in this problem they have asked you to find out Z transform of U of n. So n is equal to minus infinity to infinity. Here x of n is U of n z power minus n. Okay, and U of n value is 1. So that I need to substitute. But U of n exists only for n greater than or equal to 0. So summation n equal to minus infinity to infinity, I have to change it as 0 to infinity. Why? Because U of n exists only for 0 to infinity. And what is the value of U of n? The value of U of n is 1 into z power minus n. Okay. So now take power n outside. Okay, so what happens? Summation n equal to 0 to infinity. Anyway, 1 into any value is that particular value. Okay, so we have just z power minus n. So take power n outside. So what is the base available? Z power minus 1. Okay, so like this you rewrite your expression. So now again we have sum of infinite geometric series formula, that is summation n is equal to 0 to infinity x power n. Okay, so actually what we are going to do means just expand your series and see what happens. N equal to 0 means x bar 0, it is 1. N equal to 1 means x. N equal to 2 means x square, and this series goes on. Okay, so it is 1 plus x square and so on. So for this you have formula 1 by 1 minus, okay, whatever the second term available you have to write it as it is. So 1 by 1 minus x. Okay, so in simple, whenever I have summation n equal to 0 to infinity x power n, whatever the base available you can write as it is 1 by 1 minus x. Okay, or you can expand and write. Okay, it is your wish. So I am here going to expand your series. So when n equal to 0, okay, z inverse power 0, anyway that value is 1. N equal to 1 means just I have z inverse. Okay, when n equal to 2, z inverse the whole square. So I have to apply the formula 1 plus x square formula. So I can write it as 1 by 1 minus x. So what is x value here? Z inverse. Okay, so just write z inverse. And then since we have inverse z terms, convert it into positive z terms. Okay, so how you are going to convert it to positive z? Here z power minus 1, so multiply by z power 1. Okay, that is z in both numerator and denominator. Suppose if I have z power minus 2, then I have to multiply by z square in both numerator and denominator. So here I have z power minus 1. So just multiply by z in the numerator. So z into 1 is z. In the denominator also multiply by z. So z into 1 is z. And then z into z power minus 1 becomes 1. Okay. So therefore I can say z transform of u of n is z by z minus 1. Okay. Thank you. Thanks for watching.